Hello friends, good morning. My name is Dr. Sachin Borse. I am presently working as a professor and coordinator international relation at Imperial College of Engineering and Research. So, welcome to my lecture. My lecture is about the subject heat transfer. I will discuss in this lecture about the introduction of the heat transfer, and then we will compare with the heat what we learn in the thermodynamics. So we'll continue our first lecture on the heat transfer. So what we will do, we'll just revise the subject called as thermodynamics, because thermodynamics and heat transfer are related. So let us see how they are related. In the thermodynamics, the unit of a transfer is a joule, and in the heat transfer here it is joule per second. What is the meaning of this? The meaning is that in the heat transfer we are interested in the rate of the heat, but in the thermodynamics we are not interested in the rate. Now let us see from the thermodynamics point of view. So we know from the thermodynamics point of view that heat and work are energy in transit. So these energies, heat and work, appear only when they cross the boundary of the system. So energy and work are energy and work are energy in transit. Heat and work are energy and transit, and they only appear when they cross the boundary. So both work and heat are the energy. So if you see from thermodynamics point of view, so the work as well as heat will appear only when the system and surrounding are not in equilibrium. Please understand, if the system and surroundings are in equilibrium, then there will not be any work transfer, there will not be any heat transfer. So in equilibrium is required condition for the work and heat to transfer. So we'll see about the heat transfer. So for heat transfer to occur, there should be temperature difference, means there should not be equilibrium, then and then there will be heat transfer. So there should be temperature difference between the system and surrounding. Now let us see the direction of the heat flow. So we all know that heat flows from higher temperature to the low temperature. So if there is a warmer object which is kept in the room, then there will be heat transfer from this warmer object to the surrounding. Okay, so what will happen if you keep the warmer object in the room? It will cool down, and after certain time it will come in equilibrium with the surrounding, and once it comes in equilibrium there will not be any heat transfer. So similarly, if we keep the cold object in the room, what will happen? It will gain the heat from the surrounding and it will get heated up, and ultimately it will achieve the temperature of the room. So what is the result of heat transfer? So result of heat transfer is system and surrounding will come in equilibrium. So let us find some applications of the heat transfer. So where will we apply this knowledge of heat transfer? Any place where there is a temperature difference. In short, if the temperature of the system is different than the surrounding at that place, we can apply the knowledge of heat transfer. So in short, if we talk in terms of engineering applications, so first application is in the design of heat exchanger. So let me tell you what is a heat exchanger. Heat exchanger is a thing which transfer the heat from one object to one fluid to the another fluid, maybe same fluid or the different fluid. Then next is a condenser. It is a type of heat exchanger where the steam is condensed and converted into the liquid. The evaporator, it is again the it is one type of heat exchanger where the liquid is converted into the steam, vapor. Okay. Then gas turbine blade cooling. We know that the gas turbine blade is subjected to very high temperature gases and it need to be cooled. Then comes next application, engine cooling. We know that engine needs cooling to prevent the damage as well as prevent the burning of the oil which is lubricating the system. So heat transfer application lies in the engine cooling. And then every day we cook the food, that is also the application of heat transfer. Then comes cooling of the electronics component. Please understand here the electronics component suffer, they generate the heat, and if this heat is not properly dissipated, the life of electronic circuit reduces. So this is one of the application where heat transfer engineer works and tries to improve the heat transfer to lengthen the life of electronic component. Now let us move to the modes of the heat transfer. There exist three modes of heat transfer, viz. Conduction, convection and radiation. So these are the three modes of the heat transfer. Please understand that at a time there may be all the modes may be coming into the picture, but as an engineer we have to select the mode which is a major contributor. Sometime we may need to consider the two modes, sometime maybe only one mode because the other modes may be negligible. So as an engineer, our work is first to identify the major contributor for the heat transfer. Now move from these three modes, conduction, convection, radiation further. Now let us compare